record this one because I will need this. So this pertains to a person getting hit by a bus. The bus is moving at 30 miles per hour. So the amount of force generated by the bus is 58,000 pounds. All right, so there's going to be 58,000 pounds of force acting on this person in the direction of the motion of the bus. And the bus is going at 30 miles per hour. So this bus, I had to look this up. So evidently 40,000 pounds this is a public transportation bus, I think, is one of the numbers that I got. So this is a small size bus, is 40,000 pounds. A person is 150 pounds, so I decided that I'm a good candidate for something like this. And then I ran the advanced calculations. I think the impact time at that speed would take about less than 10th of a second. That's 100. This is 700th of a second, so that's normal. So determine the speed of the person at the end of the impact and convert it to miles per hour. And then question number B, part B of the question says, what's the expected speed of the person at the end of the impact? And does your finding agree with that expectation? Why or why not? Okay, so there's a reason why we'll do a computation. We'll do a computation because we're testing a hypothesis here. And so my hypothesis, I'm going to do B first, and then I'm going to go back to B again and justify it. Okay, based on the discussions that we had during the lecture, if the bus is going at 30 miles per hour, I would expect a person right after impact to move double the speed of the bus. All right. Being a physicist, I know this because this is going to come out, something called the conservation of energy and momentum principle. Okay, that's a lecture that we will have within a month. But I didn't, without explaining the reason why, I did a small demonstration using this pen. And as soon as I hit it, notice that there's no secondary impact. My hand can go through it right away. All right, so this gets out of the way. It doesn't stick to it. When you hit it, it gets out of the way, which means that the point of impact is going to end up moving double the speed of the car. Take my word for it. That was the discussion, and the proof is going to be provided later on. So my expectation, based on the discussion that we had, it should be double the speed of the vehicle, the bus. So the person who's getting hit at the end of the impact is going to be moving at double the speed of the bus. Okay, so when we do the computations, that's what I expect to see. Okay, so there's a hint that says this problem requires mass and force conversions. And this one can be a little bit tricky because mass is expressed in terms of pounds, the force is expressed in terms of pounds. So based upon what was provided during the lectures, I just want to make sure that you can distinguish between those two. All right, so once again, we will follow the format. All right, so the first thing I'm going to do is I'm going to list everything that I see. So this is the speed of the bus. This is the mass of the bus. All right, no, this is the amount of force acting on the person as well as the bus. This is the mass of the bus, mass of the person. You got the impact on. And determine the speed of the person. I guess there are two ways of doing it. I'm going to do it. I'm not going to list everything because I'm looking at it. I don't need everything. The only thing I'm interested in is what goes on with the person. Okay. So anything and everything pertaining to the person is what I'm going to list. Okay. I'm not going to do it in a robotic sort of way. I'm just going to do it. I see the problem. I see what's going on. I'm seeing a bunch of numbers here. So I'm just going to take what's relevant. What's relevant is the fact that this person is 150 pounds and this is the amount of force acting on this person. And on top of that, another thing which is relevant is the impact time. That's it. So I'm just going to focus on what I need. Action force is acting on the person. So what you're looking at is here's the center mass of the bus. Okay, they don't have sizes like that. These are for visual references. So here's the person. It's not as massive. Action force is acting on the person. The reaction force is acting on the bus. All right, action and reaction forces will be the same. So I'm going to say action force is acting on the person. The reaction force is going to be acting on the bus. And I'm just going to say that's just the force that I'm going to be dealing with. This is the force acting on the person. So that's going to be 58,000 pounds. Let me just make room here. All right, so this needs to be converted to Newton, so somebody just take care of that. All right, so what else do I know? I know that this person is going to have mass. Mass of this person is going to be 150 pounds. Okay, so what else? And there's an impact time that lasts 0.07 seconds. And based upon that, determine the speed of the person. What is the speed of the person at the end of this impact in terms of miles per hour at the end of this impact? And I know that the initial speed of this person was 0. And that's what we got. All right, so this is a conversion question. So for the force, you go from pounds to newtons. Roughly 10 newtons is going to be 2.2 pounds. I don't have a calculator, so I will need to answer from someone. And all right, let me just get this out of the way. We got a crunch space. All right, the second one is a mass conversion. So I will take care of this. So this is going to be pounds to kilograms. 1 kilogram is going to be 2.2 pounds. Okay, so what do you guys get for this one? I can, I'm going to go with, Eric. Okay, cool. Kind of give yourself 5 points too. And then I'm also going to go with 68.12 is also correct. 68. That I know. It's almost 70 kilograms. Cool. All right, so we're done with the step number 1. Literally, the whole idea is, do you guys know how to do the conversions? Okay, mass and force conversions. All right, so what I need. Okay, so I'm trying to figure this out. Okay, now look at the way the problem is solved. There's nothing linear about physics problems. If you understand the concept, you can solve it. If you don't understand the concept, even if you have a PhD in math, you're not going to be able to solve it because these are not math problems. You do mathematics obviously to solve it, but the problem itself is not some kind of a mathematical technique problem. This is literally, you're analyzing it. This person is getting hit. This person's body is going to go through jerking motion, which means that the acceleration is going to change. So which means that boom, which means that I'm going to be focusing on the average acceleration. All right, this is my starting point. I'm looking for V, and my V is right here. Okay, so this is what I'm going to go after. And the only reason why I know that I can use this formula is because I understand what happens during impact. Change in acceleration, person experiences a jerk. At that point, that allows me to be able to use this formula. I always pick a formula that has what I'm looking for in it. And the rest of it is I'm going to wrestle it. I'm going to wrestle the hell out of it until I come up with a solution. All right, so this is where I am. Okay, and which means that I have to solve for V. Okay, if I have any zeros, I'll plug in the zeros because it's going to make life easier. No other numbers, I'm not going to let you use them. There is a reason for it. You won't be able to anyway. These problems are set up in such a way that they're highly realistic in the way you approach them. These are not like textbook problems where everything is expressed in the correct units and somehow you got enough numbers that you can generate in order to solve a problem. Real life is not that easy. It's a lot more interesting though. All right, so what do we have? I don't want to make my algebra too complicated. So what I'm going to do, if I have any zeros, I just want to simplify the algebra. Initial speed of this person is 0. So this person is not moving in the direction of motion initially. And immediately, the math is simplified. Final speed divided by time, solve for V. Okay, I don't want to keep doing the same thing. I already advertised. All right, so which means that you got to multiply both sides by T. I'm going to show work because you guys taking college physics, not university physics. So, all right, so you can benefit from this. So it's going to be 8 times T. Okay, it looks like I'm done, almost. All right, and then I go, okay, so I'm good. Initial impression. I know what T is right here. This is what I'm looking for. All right, and then but there's a slight problem here. I don't know what this is. I don't know what this is. Okay, all of a sudden I'm stuck, but I can make myself unstuck. And how do I do that? What I'm going to do at this point, I know how to find A. All right, so A is what I'm looking for. And I'm going to find it. What causes acceleration? Force does. That's it. What causes acceleration? Force does. Notice that it's a very conceptual approach to problem solving. I understand the concepts well enough that I'm able to actually just let the problem solve itself. So I go, wait a minute, there is an acceleration here. It's the second law. The second law says force is what causes acceleration. All right. And so, which means that I'm going to rewrite this. And then I'm going to get rid of M. And I'm done. Okay, so this problem is one substitution deep, guys. Okay, this is the whole idea of the test this week. It's always formatting. So this week's question is, can you actually do a one substitution deep problem? Last week was an easier version of it. This is like a one substitution. So what that means is I'm going to be able to take that expression and just plug it into that expression. All right, so you go V, A is going to be F. I'm going to keep it in the blue. Divided by M, and I got my T. That's it. Final expression, just box it. All right, doesn't like being boxed. Okay, cute. All right, so now the next step is, let me check to see if this has everything that I have. F is this. This is the force acting on the person. It's the same as the action force. I know the mass of this person, so that's worked out. I know the impact time, that's worked out. Notice that I came up with a solution that has everything that I'm looking for in recording. All right, so that's it. So the next step is the numbers. All right, I'm still following the same format. I'm doing my algebra first, so 80% of your work is going to be in the symbolic algebra. And the final equation is going to house all the numbers that you need. So we got the force, it's going to be 263,636.36. We got the impact time, so impact time is going to be 0.07. And what else we got? We got the mass. Mass is 68.12. All right, so somebody just do the competitions and give me the number.